In this video, we will explore the idea of exponential decay. So suppose we have a function f defined as f of x equals 5 times 0.85 to the x, where y is equal to f of x. Now an exponential function written in this form shows us that the initial value of f, or the value of f when x equals 0, is 5, and this 0.85 gives us the 1 unit growth factor. So our 1 unit growth factor for this exponential function f is 0.85. A 1 unit growth factor of 0.85 means that whenever x changes by 1, if x increases by 1, then y becomes 0.85 times as large, where the value of y at the end of that interval is 0.85 times as large as the value of y at the beginning of that interval. So in this case, if x varies from 0 to 1, y starts at a value of 5, so it starts at a value of 5 and then becomes 0.85 times as large, and 5 times 0.85 is equal to 4.25. And again, if x varies from 1 to 2, a change of 1 unit, then y will again become 0.85 times as large, and so y will be equal to 3.6125. So we see that as x increases, y is actually decreasing, because each time x changes by 1, y becomes 0.85 times as large, which means y is becoming smaller. The graph of this exponential function is shown here. So we see that as x increases, if we move our finger to the right along this x-axis, we see that the output value is decreasing. So as x increases, y is actually decreasing because we have this 1 unit growth factor that is smaller than 1. So in general, whenever we have an exponential function where our 1 unit growth factor is less than 1, then we actually have exponential decay, where our output value decreases as our input increases.